Hey there, Kimmer here. Today I'm going to show you arrays and pointers and talk about how they're similar and how they correlate to each other. You'll notice here that I have an array that I already initialized. It's a float array called prices, and it has a size of 4, so you'll see there are 4 elements in my array. And I have 233, 455, 677, and 899. So if I want to just print these, let's create a function that will print the contents of this array. I'm going to call it print prices. Don't forget, when you have an array, in main we need to then send it, so we're going to have to catch it here. I don't have to put the size. We'll talk about that more in just a second. There's my function. It's going to catch an array. So let's call it. When you send an array to a function, you only send the name. Like so. We're going to include a little for loop. That will go ahead and print the contents of our array. And a couple of spaces in between each one. This should then print the contents of the array. I'm going to put a couple of spaces in the output so you can see it a little bit better. Okay, now that our function is done, we have to go ahead and put in our prototype. So I'm going to go ahead and do that. Remember, you can choose to keep the name in or take it out. I just like how it looks from this standpoint. Okay, let's save it, compile it. And no errors, no warnings, that's good. Let's go ahead and run it. You will notice that it's 233, 455, 677, and 899, which are the exact same values that I had in my initialized array. So of course there's really nothing new here. So now we can start in with the new things. The first thing I want you to notice is that I'm going to change the function header, and I'm going to say, I tell you what, let's not take in an array, but rather than, let's make it a pointer. I'm going to make my prototype match. That's the only change I made. We're going to go ahead and save it, compile it, and run it. And you will notice nothing changed. So let's understand what's going on. When you send this array to the function, you remember what you're really sending. When you declare an array in memory, there are 4 different spots in memory that these particular values are going into. The important thing is, prices keeps track of A1. So what's inside of prices? A1. When you say send prices, what are you really sending? A1. And what is A1? A1 is an address. And you remember what a pointer is? A pointer is a variable that can only contain an address. An array name, right here, and a pointer, right here, both contain an address. So they work very similar. Knowing that, as far as the computer is concerned, it knows it's getting an address here and catching that address right here. It will do the exact same thing that we expected it to do. So does that mean we don't have to use this subscript here? Can we just give it a pointer, such as this? Let's try. Save, compile, and run. You'll notice that if I try to run it this way, I get the exact same number 4 times, which makes perfect sense. It's going to tell it to go to whatever address I have in prices. which comes from my main, which then is that first location, 2.33. Even though we can use a pointer, in this case, in the header, we can't necessarily display all of them like this. However, we can tell it to take that address and add X. Let's try it this way and see what happens. We're going to go ahead and save, compile and run. And we get 233, 333, 433, and 533. Now if you'll notice, those are not our numbers, but they do change this time. What do you think is happening? If we go ahead and code it like this, it's going to take the 233 from here and add to it whatever's an X. So if you'll notice, the first time it was a 0, so 233 plus 0 is this. The next time is 233 plus 1, which is 333. The next time it's 233 plus 2, which is 433. And the last time it's 233 plus 3, which is 533. So ultimately, this is still representing 233. It's not changing anything. There are two ways we can fix this. One is to tell it using parentheses, order of operations. Basically telling it to take prices, which is an A1, and add a number to it. So if we're assuming that this first number is in location A1, A1 plus 0 is still A1. Go to A1, we see a 233. Let's try this. Save, compile, and run. You'll notice now I get my 233, my 455, my 677, and my 899. This worked. This is basically saying take the address and add whatever number to the address and then go. So if it's A1, add 0, it's A1. If we say A1 plus 1, A1 plus 1 is 2. A1 plus 2 brings us to A3, etc. This is known as pointer notation. The previous definition that we used with the brackets was known as subscript notation. Now let's take this one step further. We're going to take pointer notation, but we're going to change it up just a little bit, just to make it a little neater. What if we actually said, let's just take whatever address you have and increment it. In other words, we're dealing with a pointer, so we can change it. So it starts at A1, and it's going to go ahead and print what's at A1, and then we're going to change A1 to an A2. So we're literally changing the value of our local variable right here. It is not changing the actual starting address up here. Only this local pointer variable. So let's give it a shot and see if it works. We're going to save, compile, and run. If you'll notice, 233, 455, 677, and 899. It works. So there's a couple different notations. There's pointer notation, subscript notation. This is called using pointer arithmetic. Lots of different ways. But really, you're just playing with addresses, whether it's an array or a pointer. They work very much together. I hope this helps. We'll talk to you soon.